Here's 2-1, day 2. Still talking lines. There's kind of some different aspects of linear functions. Again, that first day we really kind of put a writing equation focus and a graphing focus. The writing focus will stay here at the latter half of this lesson. We'll write some linear equations from problems that have a context to them, right? Basically some word problems. But the idea is the same, to write an equation that would represent kind of the situation. And then we're also going to work a little bit with lines that are parallel and perpendicular, which really kind of means just diving into slope, okay? So we'll define both cases first of all. If lines are parallel, it's pretty straightforward to observe. They've got the same slope, okay? They've got the same slope. Lines that are perpendicular, this one's a little bit of a different scenario. It's much more wordy in terms of the vocab, but the idea isn't terrible. They are the negative reciprocal of each other. You might be reading that thinking, yeah, that's a pretty nerdy term. Negative reciprocal. Yep. What the heck does that mean? All right, so typically a slope would be written as a fraction. So if you want to think about it in kind of simpler terms, flip the fraction and switch the sign. Okay, we'll see some examples of what that looks like, but the biggest thing is to kind of know it when you see it, right? Top number, bottom number, switch that. If the slope was negative, it's now positive. If it was positive, it becomes negative, right? That's the relationship that goes on if you got two lines that are perpendicular, okay? Big thing, though, is the relationship between parallel and perpendicular between two lines always shows up in the line slope, okay? The y-intercept doesn't mean anything, okay? We wouldn't look at that. All about slope. So down here in part A, I'm going to call it M1. So I've got, two lines, each going through those 2 points. So I want to, determine parallel, perpendicular, or neither, which, okay. Basically, I'm just going to find the two slopes. If they're the same, it's parallel. If they're negative reciprocals, perpendicular. If neither one of those things is going on, then we'll say neither. All right, so for line number 1, we get -1. Here's the slope of the second line. Which would be 2/2, which is 1, okay? Now, right off the bat, I'm ruling out parallel, okay? These slopes aren't the same. This one is a little bit tricky to see. It's kind of the one case with perpendicular. Probably not a great one for you to see the first time, because this whole negative reciprocal, like the sign is opposite, right? So that fits. One was positive, the other was negative, right? But is this whole, you flip the numbers thing going on? Well, it's hard to tell because the numbers are the same, right? Really, when you get down to it, slope number 1 is negative 1 over 1. Slope number 2 is 1 over 1. But think of, to get from the first slope to the second, could you switch the numbers and flip the sign? Okay? Well, yeah, I mean, flipping the numbers makes no difference, right? You're swapping a 1 and a 1, so yeah, you could flip the numbers and then change the sign. But those two are indeed perpendicular, okay? We'll come back to another one I think on the next slide, and I'll show you. Okay, here's the little more obvious case where, you know, the top number of the fraction and the bottom are two different numbers, okay? And then it's a lot easier to see that, oh, the numbers did switch places, okay? Same thing on B. Five minus 4 over, whoops, got to be careful there. I was about to make a mistake on slope. I got to keep that order the same. I went 5 minus 4, so I got to go 2 minus negative 1. That'll get me into some trouble. And you know me, I don't want any trouble. Don't want any trouble. All right. Looks like 1/3 for the first slope, okay? So now this one would be an easier case, right? Just to kind of stay on this perpendicular thing. If I were looking for that case, right, the 1 and the 3 would switch, and the slope number 2 would be 3 over 1, and then we'd have to have a negative sign with it, all right? So just to kind of get ahead of looking at that, negative 3 is the slope I'm looking for if they're perpendicular. Not saying they are, okay, because they may not. Rather, they actually come out to be the same, and that's your parallel case, right? Those two lines would be parallel. By the way, probably worth a reminder here with the definition of these two terms. Parallel lines, they just run next to each other. They would never cross, okay? Two lines that would never cross. Perpendicular, they meet at a 90-degree angle. Okay, definitely worth getting those ideas out there. All right, so we've got a line, 2x minus 3y equals 5. That guy is right here. We're going to find the equation of two lines. The first is going to be parallel to that line, and the second of which is going to be perpendicular. Okay, so really the rest of the lesson here, we're going to be writing equations. Remember, anytime I say that, what I mean is we have a little bit of information, okay, and we need to get the equation of a line. And we have said for our final answer, slope-intercept form is a fine way to write it. But we need to get the equation of a line that fits the data that we were given. Okay, that's what we're after. First part's going to be to find the line that's parallel, right? So two things here. It's got to be parallel, but here's the other piece. That's actually not enough to get an equation, because if I found a line, there's a lot of lines that are parallel to it, okay? Technically, there's an infinite number. The line I need to find the equation for has this very specific detail. It has to go through the point 2, negative 1, okay? Now, first things first, the whole relationship of parallel, again, is all about slope. The two lines have to have the same slope. This line was given in general form. I can't tell the slope, okay? That's no good. Nothing against general form. It's fine. Nothing against it. But if I can't tell the slope, this problem is going to be a struggle. So this equation that was given, I got to work with this a little bit. Essentially, I just want to get it solved for y. Y-intercept, I don't really care about that much. This is what I'm after, to see that the line that I was given, it has a slope 2/3, okay? So now I've got a slope, I've got a point. Think back to yesterday when we had our third form of a line called point-slope form, okay? Y minus the y-coordinate that I know. That's from the point that was given. Now it's parallel, so I got to use the same slope. Right, it's parallel, so I got to use the same slope. This line, again, it's going through the point 2, -1. Got to have a slope of 2/3. Getting rid of my parentheses, which I believe this will give me minus 4/3. Subtract 1. I got y all by itself. There's my slope. Again, that's the same at 2/3. Different y-intercept here. Looks like it's going to be -7/3. Okay? So again, that line that we just found, here's what I know about it. Two things. It is parallel to the one that was given, and it goes through the point 2, -1. All right, now on part B, pretty simple process here. The point still has to go through 2, -1, right? The only difference now is this line has to be perpendicular, okay? And this is the problem I was talking about, that this would illustrate much, much better what we're looking at to see this whole relationship with the two lines being perpendicular, right? Because the top of our original slope from the line that was given, right? The top and the bottom number are different. So now for the slope that I have to use down here, because I want it to be perpendicular, 3/2, right? Those numbers switch, and then it was positive, so I have to add the negative. And from there, I'm just going to mess around with stuff to get it into slope-intercept form. Looks like here that will actually be +3, right? That's coming from -3/2 times -2/1. Yeah, that would be 6/2 or 3. Oh, subtract 1. Y is -3/2x plus 2, okay? That one also goes through the point 2, -1, but instead of being parallel to our original line that we were given, that one's perpendicular, okay? All right, last two problems. We're going to stick with writing equations, okay? Except we're going to do it in a real-life context, all right? So same deal. You should be thinking about, like, all right, we need to figure out what x and y is, right? That's big, because that determines how you write the equation. We need to find some points, and we need to find a slope. That's what I should be after, because right here, you see in step number 4, right? We're going to write an equation the same way we have. We want to go to point-slope form, right? Which is y minus the y-coordinate is x equals the slope times x minus the x-coordinate, where m is the slope and x1, y1 is the point that we know this line goes through, okay? We got to get there. We just got to sift through all the context to get this information. So Under Armour's sales were approximately $25.3 billion in 2013, $27.8 billion in 2014. Okay? From only this information, we want to write a linear equation that gives the sales in terms of the year, so we could then predict the sales for this year. Okay? So this year would be 2020, right? So we'd use our line to get a ballpark estimate of what Under Armour would think maybe their sales would be this year. All right, first things first with my variables. X is going to be time, And the way it's written here, I'm going to say years after 2000, right? What this does is it gives me two ordered pairs here. That the first one, I can say X is just 13, and then Y is going to be sales. In billions of dollars, right? That's not a normal thing for us to have to come out and write that down. But if you're writing the equation from like the context of the problem that's given, you need to, right? Because usually when you're not writing the equation yourself, you've got variables that the problem defined for you, okay? You might skim over that like part of the problem quickly and maybe sometimes miss it, but it's there. That, oh, if this was a word problem, here's what X is, here's what Y is. We're writing the equation, so we got to say. Okay? Next thing, once I have my variables defined, slope. 27.8 minus 25.3 over 14 minus 13. 2.5 over 1, or just 2.5, okay? That's a big step right there because I had the 2 points, okay? But that's not quite enough to use point slope form, right? Having 2 points is great. I only need one to write the equation in point slope form, but I also need the slope. Okay, so anytime in an application problem that's missing, you'll need to get it, right? Especially if it's almost automatic. You're like, hey, I'm writing the equation of a line. It gave me 2 points. You know, it doesn't matter if I do it sooner rather than later. I got to get the slope at some point, okay? I'm not going to be able to finish the problem without it. Now that I've got that, I'm going to step down here. All right, Y. Just for whatever reason, I'm going to use this point right here. Minus 25.3 equals 2.5. That's the new slope that I found. Times X minus 13. We're going to go from point slope form to get it to slope intercept form. Got to distribute this 2.5. 13 times 2.5 is going to come out to be negative 32.5. And then I'm going to add Y is by itself, so we're getting close. 2.5x minus 7.2. That equation, again, if you put in the number of years after 2000, would give you a relatively decent estimate for Under Armour's sales. All right, so it said for this year, that would mean for X, let's put in 20, because it's 20 years after 2000. So I go 20 times 2.5 minus 7.2. $42.8 billion would be our rough estimate as to where Under Armour is at this year in terms of sales, right? Based off of their data from 23 and 2014, right? That data is 6 to 7 years old. If they had any kind of growth in sales that changed, that number could be off. But from that information, that's the best estimate that we could get. Okay, let's do another one, okay? Always good to see a second one because there's a lot going on, right? This one is not involving sales, right? This one would give us a model to try to predict the population of Minneapolis, okay? Just want you to see all the same parts again. First things first, we need some variables. This is just a coincidence. I don't actually love that both ended up being the same. Your X variable is not always going to be time, and it's not always going to be the years after 2000. both of these examples with the data we had, that's just what X should be. Okay, don't get into that habit that that's automatically what it is. Your Y variable, that's the population of Minneapolis. Okay. And by the way, just to clarify here, having defined that, I have two pieces of data. When T is 0, or the population in the year 2000, it was 382,688. And then when X is 16, 415,622. Okay? That's going to be a really common theme, that to write this equation, I need two ordered pairs, right? I got to have that. Because, right, I know, eventually down here, in fact, I can already kind of start to write it out. I can go to point slope form. I'm like, okay, 382,688. I can plug in either point. M, I don't know what that is, right? But I ended up just using this point right here, right? Slope is missing. It didn't tell me what the slope was from 1 year, for the average rate of change for Minneapolis population. So I got to find it. To find it, I need 2 points. Right? That's just like a constant thing with lines, is you got to have 2 points. That's why you got to identify the two ordered pairs. Really important, because it sets you up to find your slope. Minus 382,688. We'll simplify it to a decimal here just for the sake of space. End up getting that. I have to give myself some more room down here. It's a little bigger slope, right? It's over 2,000. Now, in the context of the problem, what that number really means is between 2000 and 2016, on average, the population of Minneapolis went up by a little over 2,000 people per year. Okay, that's how fast it's growing. I can do both of these in one step, right? You'd have to distribute it, so I'd have to pair it with the x, but notice out here, this is kind of the unique situation that my my x coordinate is 0. Now that's kind of a significant thing. I didn't really mention it. You might have picked up on it. This point right here, x was 0. That's the y-intercept, okay? This problem was a little different from the Under Armour one, that one of the 2 points that was given happened to be the y-intercept, okay? So I've got my slope, so actually what I'm expecting is this number right here is what's going to be added on the other side. And sure enough, that would cancel. I added over here as well. Because the constant over here is 0, so I'm adding it to nothing. And we get 382, 688. And there you go. That linear equation. Right? Whatever year you had, right, in terms of... the problem doesn't say to do it for this one, so I'm not going to. But, if we wanted it for this year to get an estimate, we could just say, hey, let's put in x is 20. This should be a decent estimate for the population of Minneapolis in the year 2020. All right, that'll do for 2-1, day 2. Again, whole focus is lines, just kind of, taking what we did in chapter 1 and kind of taking some of the next steps with our skills with lines.